Okay, welcome to my channel, The Engineer's Edge. In this video, I will explain the ebook that I have recently published, and it is available for sale on the link in the audio, which is given in the description. So it's about the script for Python in ABAQUS for creation of repetitive loading functions for dynamic analysis and it's visual from the title page. It's telling us that it's about the NDF methodology for automating the creation of cyclic loading protocols that are tailored for ABAQUS simulation. So it's introduced a Python script specially designed to generate repetitive loading data, which is essential for accurately simulating the stress scenarios such as loading. So about me, uh, I'm the author of this book, and just in case if you want to connect with me, these are my WhatsApp information. If you are residing outside Pakistan, then you have to use the country code +92 344 090 787 4. If you are in Pakistan, you don't need to use it. This is my email, and this is my LinkedIn profile link. But usually I prefer WhatsApp for communication and avoid email. About the contents of the book that I have published, it comprises of introduction. Then we have six chapters, and then I have this appendix code at the end of this book. Just in case if you are lazy and don't want to practice with me, then you can use this appendix code, just copy and paste in Python ideally and use it here. I have an introduction about the author, which is definitely about me, and I will discuss that in this course. And I also have the methodology for integrating the amplitude and ABAQUS that we are generating here. And for that, you need to go to the lower module. You need to go to the modeling tree and click on it, uh, and then use the results that we are going to develop here. So for this, I will dive into the world of dynamic analysis in ABAQUS and explore how Python can be a powerful tool for creating amplitude functions. And this is only the first volume, so I will only discuss about a single case of repetitive loading that you can use in ABAQUS and other stuffs. It's a very user-friendly book. I have discussed the flexibility of Python for automatic loading. There is a link for the Python as well, just in case if you want to use it. And I have discussed this whole scenario and the book that what you can do with the Python and how you can utilize it in ABAQUS environment. So I'm on page 5. Uh, I also have opened the ABAQUS, and here I'm going to use that amplitude function that we are going to generate with the Python script. So let's create a new uh, file and call it demonstration of the Python ABAQUS automation script, and we are going to name it with py, right? So the name is different. The actual name of this function and the ebook is going to be repeat your data, and we have this ebook with a complete methodology that is given over here. And if I go to 14 page, I'm on page 5. You can find out about the uh, author, which is obviously me, and you have this methodology given over here with how you can use it, right? So let's go back to the first page, go to the setting of the environment variable, and also I have launched the ABAQUS. So I'm going to create a part for it as well and call it, let's call it a cube, or whatever function we want to use, we can use it. It should be um, something like this. And I'm going to create a function, but before that, I need to switch off the view for the grades here and lock it. Then I can do something like this. I will make it an equal distance profile or here, and similarly here. Then I will use the equal length constraint. That's going to be uh, working with pressing shift, and this constraint will be same for all. So let's include the dimension of 100, and there we go. Usually I prefer scripting for it as well, without spending too much time on it. Anyways, I just created this simple, and let's assume that I have the property that is going to be a road, and we have the single layer in subgrade. So let's say I have this density of 2.3 e minus 9, and I have elasticity of 2345 MPa, and uh, Poisson ratio that is given over here, and I have this viscoelastic definition for the time, and let's make it zero point 0.5, zero point 0.5, and 12. This is not a realistic data. For realistic data, these parameters you need to perform IDT testing. But anyways, um, let's create a section and call it section 1 and call it a road profile, and there we go. And let's uncheck this and assign these properties to it. And I'll quickly go to the assembly, and in assembly I have these independent parameters, and let's go to step, create a cyclic loading or repetitive loading step, right? And for this repetitive loading step, um, we can apply approximately we will decide this based on the script, this time period. So let me add, we have to the scaling from the Python script results, and I'll demonstrate how we can use the scaling, switch it on, and incrementation will be changed as well. I would prefer symmetric, so I will keep it like this at this moment and then change the step here. Let me save this with the road profile, And after that, I don't need any kind of other details except I have R. Um, I need S, U, and E. Right? Click on OK. And I will call it global response. I prefer this one. And for this, I can create any set. Before going to other details, I need to go to the tools, um, set manager, and um, call it routing depth. But for routing depth, I need to first mesh it. So let's go to introduction. We don't have any introduction at the moment. However, we need to consider the base for this model, and let's call it n, right? And uh, and let's go to tools and set manager and call it periphery of the road. And since it's a micro model, we are going to define this set for it, and done. So now even if I define that set, it's going to be uh, periphery of the road, and let's call it set u1 u2 u1 u3, and we cannot rotate about r1. Yeah, someone have to use these properties. You can use it by itself. So anyways, let's go back to the book, and for this ebook, we need to create this loading protocol that I have discussed in detail. This is the integrate amplitude and abacus that's given here. I will discuss them one by one. So let's continue and start working on this profile.